This is a video about number 7, in which we are going to deal with a systems of inequalities word problem. So Earth is sending a fleet of more than 5 transport vessels to collect pickle bears. So we know we have something that's about being more than 5, so greater than 5 is going to be in here. Some of the vessels are larger and can hold 8 pickle bears. Okay, so we know we have one type of vessel that holds 8 pickle bears for every X number of those vessels. We have another vessel that's smaller that holds 6 pickle bears for every vessel that is there. And Earth wants to collect as many as 48. So we're going to have a less than or equal to. I'm going to do this quickly and just write it that way. That means less than or equal to on this screen. Less than or equal to 48. So they can go up to 48. Now, we also know that we have 2 types of vessels, and there's going to be more than 5 of them. So X plus Y is going to be more than 5. We have to have more than 5 vessels. All right, there's some things we can work out here. So first thing we got to work out is what the boundary lines are going to be like for these inequalities. If you recall, we're going to graph some sort of line that works as the boundary for the parts of the graph that are not part of the inequality and the parts that are part of the inequality, that are solutions for that inequality, that make it true. So these are both basic standard form structures here. In this case, I have coefficients of 1 and 1. If X were 0, then I'd have Y as greater than 5. So I have a point on my boundary at 0, 5. And if Y were 0, then X would be greater than 5. So I have another boundary point at 5, 0. So those are our Y and X intercepts. You might remember that we had cheat codes for X and Y intercepts. For the Y intercept, we had 0, C over B, and C is 5 and B is 1, so C over B is just 5. And for an X-intercept, we had for the X-intercept C over A, the coefficient C, which is 5, over the A coefficient, which is 1, 0. So those would both give us the same points, give us 0, 5, and 5, 0. All right, I'm going to go over here to Desmos, where I have my 2 inequalities in. I'm going to put in my X-intercept and my Y-intercept. All right, those should not be solid, though, because this is not an or equal to, so I'm going to make them hollow. So they're open points. Now, I would just get my straight edge, and I'd draw a line through that, but it would be a dashed line. So it would be X plus Y. I'm going to use equals 5 now so that we can have that line. And now I'm going to just make it a dashed line like that, so we know that it's an inequality style. And now we got to figure out which side would be allowed in that inequality. Well, we can use a test point. And the test point I'm going to choose is 0, 0, because that's the point I like to choose. 0, 0. Is that in the inequality? If 0 plus 0 is greater than 5, then 0, 0 would be on the shaded side. But 0 plus 0 is not greater than 5, so it is not part of the inequality. And in fact, the inequality gets shaded on the other side. And there it is. It's shaded on the other side. Now I've got to do the same thing with my other inequality. So in this case, I'm going to go back in here, and if you remember, once again, use this structure to find the intercepts. So I'm going to actually switch them, so I do it kind of in order. So C over A is my X-intercept, so that's going to be 48 over 8, comma 0. And that's the same as saying 6, comma 0. So that's my x-intercept. And my y-intercept is going to be 0, 48 over 6. And that's going to give me 0, comma 8. So I've got an x-intercept at 6 and a y-intercept at 8, and they are solid points because it is an or equal to inequality. So let's do that. So I had by myself 6, 0, and 0, comma 8. So I have my 2 points. I'm going to move it so you can see them. All right, now we're going to see if 0, 0 works for this inequality. So 8 times 0 is 0, and 6 times 0 is 0. So 0 plus 0 is less than or equal to 48. That means that 0, 0 is on the winning side, and we will be shading this side. All right, but before I get ahead of myself, let's go ahead and do our boundary line. 8x plus 6y equals 48. Goes right through those 2 points. That's what we expected. And now we will turn our inequality, and we'll see which side was shaded. And that side was shaded. We were right. 0, 0 was part of that inequality. And this zone here, where they're overlapping, is the zone where we can find the number of ship combinations. Of course, there are a couple issues. We can't have ships that are negative numbers of ships, so we're going to have to make it clear that x is greater than or equal to 0. And we're also going to have to make it clear that y is greater than or equal to 0. And so that's that zone. I'm going to copy that restriction up to my other inequality. And now it's a little clearer what is shaded. So this is the zone of possibility. Of course, there's one additional issue, and that is that there are not going to be fractional numbers of ships, nor are there fractional numbers of pickle bears. So the only points that will actually be valid will be integer points. So 0, 8, 0, 7, 0, 6, 1, 6, for example, 1, 5 would be a combination would be possible. So only those points that happen to fall on integer points. I'm not going to detail all of them. A couple of you did do that on the test, and that was exemplary work. So here you go. That's the video on number 7.